Here's a skill that's been keeping American industry safe and running for over a century: hand splicing steel cable. The folks at Dakota Riggers and Tool Supply are demonstrating a technique that's equal parts craftsmanship and critical safety procedure. What they're doing is called an eye splice, and it's the art of joining two cable ends together or creating a permanent loop without using clips or swage fittings. Instead, they're weaving the individual wire strands back into the cable itself, creating a connection that's actually stronger than the cable's rated breaking strength when done correctly. Watch how methodically they work. Each strand of wire rope gets carefully unlaid, then tucked back through the standing part of the cable in a specific pattern. It's usually done in 3, 4, or 5 complete tucks, depending on the application and load requirements. The pattern matters. Get it wrong, and you've compromised the entire rigging system. This old-school method has been trusted on construction sites, shipyards, and industrial facilities since steel cable was invented. Why? Because when properly executed, a hand splice distributes the load gradually along the rope's length, rather than creating a stress concentration point, like mechanical fittings can. Sure, modern mechanical connectors are faster, but there's something irreplaceable about a craftsman who can splice cable by hand. It's knowledge passed down through generations, the kind of skill that built America's bridges, lifted its steel, and hoisted its buildings skyward. Now we're getting into some serious metal forming, the W11 Series 3-roll symmetric plate bending machine. If you've ever wondered how those massive cylindrical tanks, pressure vessels, or industrial pipes get their shape, you're about to find out. This machine uses 3 rollers arranged in a symmetrical triangle configuration. The top roller sits in the middle and can move up and down, while the 2 bottom rollers stay fixed in position. It's a beautifully simple mechanical principle that's been bending metal since the early days of industrial manufacturing, though these modern versions have power and precision our grandfathers could only dream about. Here's how it works. The metal plate gets fed between the rollers. As the bottom rollers rotate and drive the plate through, that top roller presses down with tremendous force, gradually bending the metal into a curve. By adjusting how far down that top roller goes and how many times you feed the plate through, you control the radius of your bend. Want a tighter curve? Lower that roller. Need something gentler? Keep it higher. The symmetric design we're looking at here has one characteristic quirk. It leaves flat sections at both ends of the plate after rolling. Those straight edges happen because there's no bending pressure at the very ends when they pass through. That means operators need to do what's called pre-bending, using either a separate press brake or clever manipulation of the machine itself to bend those end sections before the main rolling process. It takes real skill to operate one of these machines properly. You're reading the metal, feeling how it responds, making tiny adjustments on the fly. Too much pressure too fast, and you'll crack or buckle the material. Too little, and you'll need multiple passes that waste time and energy. The best operators develop an almost intuitive sense for it. They can look at a piece of metal and just know exactly how it'll behave. This is the kind of fundamental metalworking that built America's industrial backbone, transforming flat steel into the cylindrical forms that became our storage tanks, our pipelines, our industrial infrastructure. You know, there's something deeply satisfying about watching skilled craftsmen work with fire and steel, just like the blacksmiths of old. Here at the Czech Republic Forging Association, they're keeping those timeless traditions alive while embracing modern precision. What we're witnessing is a fascinating blend of heritage and technology. The Czech Republic has been a center of metalworking excellence for centuries, and these forging shops carry on that proud legacy. The process begins with carefully selected steel billets, heated in gas-fired furnaces to precisely 200 degrees Celsius. That's about 200 degrees Fahrenheit for us. At this temperature, the steel glows a brilliant orange red and becomes malleable enough to shape. Watch as the forge master positions the heated billet under the power hammer. These aren't your grandfather's hand hammers. These are hydraulic giants capable of delivering 5,000 pounds of force with computer-controlled precision. Yet the skill required is every bit as demanding as it was 100 years ago. The operator must read the steel, feeling how it moves, knowing exactly when to strike and when to rotate the piece. Now comes something particularly interesting: the marking process. Each forged component receives its identification stamp while still hot. This isn't just bureaucracy, it's a matter of pride and accountability. The association uses a specialized pneumatic marking system that stamps each piece with a unique identifier, the shop number, and the date code. This system ensures traceability. If this part ends up in an aircraft engine or a ship's propulsion system 30 years from now, someone can trace it back to this exact moment, this exact forge. The beauty here is that they're maintaining the soul of traditional forging while meeting modern aerospace and automotive standards. It's craftsmanship you can depend on. Take a good look at this beauty, the Hermel C60 UMT, manufactured by Berthold Hermele AG in Germany. This 5-axis milling and turning center represents the pinnacle of precision manufacturing, the kind of machine that would have seemed like science fiction back when some of us started our careers. What you're witnessing here is the machining of a turbine impeller disc using a specialized fir tree cutter measuring 1.2738 millimeters. That tiny tool is carving out the slots that'll eventually hold turbine blades in place. Critical work for the energy sector, where precision isn't just important, it's everything. The magic of this Hermel machine lies in its 5-axis capability. Remember the old days when we'd have to reposition a workpiece multiple times to machine different angles? Those days are gone. This machine can rotate and tilt the cutting tool in 5 different directions simultaneously, allowing it to carve complex 3-dimensional shapes in a single setup. That means better accuracy, smoother surfaces, and fewer opportunities for error. The fir tree slot you're seeing cut here gets its name from its shape. It looks just like the profile of a Christmas tree when viewed from the side. This isn't decorative, it's functional engineering brilliance. That interlocking design creates a mechanical bond that can withstand the incredible centrifugal forces inside a spinning turbine, forces that would tear lesser connections apart in seconds. This kind of precision machining, where we're talking tolerances measured in microns, is what keeps our power plants running, our aircraft flying, and our industrial world turning. It's modern technology standing on the shoulders of mechanical principles that haven't changed since the Industrial Revolution. Now here's something that'll take you back to the golden age of American manufacturing, when we built things to last and fixed them right. What you're watching is Caterpillar's certified rebuild program for the 345B excavator. And folks, this isn't your typical repair job. This is engineering artistry at its finest. Caterpillar calls this their highest level of overhaul, and they're not kidding around. Instead of just patching up what's broken, they're essentially giving this machine a complete rebirth. The process starts with a total teardown, right down to the bare frame. Every bolt, every component, every system gets pulled apart and inspected with the kind of attention to detail that made American industry the envy of the world. Here's where it gets impressive. They're replacing over 7,000 individual parts with brand new, genuine Caterpillar components. 7,000. That's not a rebuild. That's a resurrection. And they're not just putting the old girl back together the way she was. No sir, they're upgrading her with the latest technical improvements, both software and hardware, bringing decades-old iron up to modern standards. The real kicker? When they're done, this machine gets a brand new serial number and a full warranty, just like it rolled off the factory floor yesterday. For contractors and heavy equipment operators, this program is a godsend. You're getting the performance and reliability of a new machine. We're talking the same power, the same precision, the same dependability, but at 40 to 50% less than buying brand new. It's the kind of smart business decision that built this country. Why throw away decades of solid engineering when you can bring it back better than ever? This is how we used to do things. Quality that lasts, craftsmanship that matters.